Hi, it's Amr the Math. Easy solution here to discuss some more trigonometry and look at the derivative of sine x and using the definition derivative. So let's say we have a function f of x equals sine x. Before I try to derive this derivative, I'll just graph it. And so we'll start by graphing it. We'll just here's a x and y axis is y, x. So we'll just graph it just to see what it should be. So this is basically how sine would look like. It would look something like this and whatnot. So basically, the derivative is just a slope of it, and then at these points where it goes down, this is the slope is 0, or f prime is 0. That's slope is 0. Slope is 0. This is 0. Slope is 0, and this one here is 0 as well. So then if we were to draw the derivative, so yeah, if we were to draw the derivative, let's just draw on this graph here, these parts where derivative is 0, if this is, let's say, f of x equals sine x, then if we draw in a derivative, at these points the derivative is going to be 0. So here is going to be 0, here is going to be 0, and these are, yeah, and then over here is 0, and then over here is 0 as well. So basically, yeah, and then at these point here, this slope here, this slope right here, so basically we have something like it's rise over run, right? So then this one will be, well, sine x over x, but the sine x here is 0. So the rise here, this one is, they're both roughly 0. And this one's close to 0 as well. So near this point, you have a small number, let's say 0.00 something, 1, by 0.001ish or whatever. So the derivative here is roughly 1 because they're both nearing 0, and so the slope looks like it's 1. It looks like a linear here. So then if it's 1, we'll just say it's 1. So then it would be like this. And then these point here, let's say it's all the same, symmetric. So then here's again it's gonna be a negative 1 because this is going down, this is going up. So then we'll go have a negative 1 here. Just go negative 1 here, so this point right here is gonna be, let's say, negative 1. So it would look something like this. So here's it's gonna go back down to 0, and here's a negative 1, negative 1. So it would look something like this, and this would be, let's say, f prime of x. And if you've seen my other video, this looks like cosine. So basically, it looks like cosine function, because yeah, if this is pi over 2 for sine, or 90 degrees, so then it's 0 for yeah, it goes to 0 for cosine of x. So it looks like cosine of x. So we can just guess, I'll show you that this is true, that f of x equals cos x. And this is true actually, but I'll prove it right here using definition derivative. So basically, if we have f of x equals sine x, then f prime of x using definition derivative is equal to limit h approaches 0 of f of x plus h minus f of x all over h. And if we write this out, this is going to be limit h approaches 0 of sine x plus h minus sine x all divided by h. Now, if we use my identity here, the one I proved before, my trig identity for sine addition, we'll get, this is going to equal to limit h approaches 0 of this sine x here. This one's just going to be equal to, what is it? Yeah, it's going to equal to sine x cos h plus cos x sine h. And then yeah, so this here is sine x plus h. You can see my other video on this, or it's on the info below, you can see it, how to derive that, and then minus sine x all divided by h. So now if we rearrange this, get the the terms of like together, like the sine x here, we'll get limit h approaches 0 of this sine x. We'll just rewrite it so it's a bit better. So sine x this is going to be cos h minus 1. Just put these together. This one and this one. Okay. Alright, so now sine, and then this side here is going to be plus cos x sine h, all divided by h. So now we have a limit of two separate things here. If we were to write this, I'll simplify this even further. Sine x is not, this one's not a function of h, so we can take it out of there. So we can go sine x. So if we simplify this all into two limits, we'll get sine x cos h minus 1 over h plus, well, the cos x is not a function of h, so we just take it out, doesn't affect it. Limit, we just divide h by on both sides, so we get limit h approaches 0 of sine h over h. So now we have two different limits we got to do. But I've already showed you in my other video that this limit, see a video in the links on the info, this is equal to 1. So then this is just going to be sine x limit h approaches 0 of cos h minus 1 over h plus cos x. Okay, so now we got to prove that this one here, we have to derive this one. We don't know what this one is. So to prove this, we'll just do this separately. We'll go limit, so limit cos h minus 1 divided by h. We can't just put h inside this because we're going to have this cos 0 is going to be 1, so 1 minus 1 is 0, so 0 over 0. So we can't do that, but what we could do, we can multiply the top and bottom by cos h plus 1 and cos h plus 1 at the top and bottom. So we do this top and bottom just so we can get this into a form of a limit we could actually solve, because we don't know how to solve these ones right now. So then if we multiply this out, this is going to equal to, this is going to equal to, well, basically this times this is cos squared h, and then this is cos h plus 1, but then it's going to be subtracted by cos h minus 1. That's why we have a plus here. If it's anything like this, so then we eliminate the one where they add. So this is cos h times this cos squared. This is going to cos h minus cos h, so they cancel. So we're just going to be left with, so this 1 times this is negative 1 squared, or 1, all divided by h cos h plus 1. Now we know that my other video, you can see the proof on it, is sine h squared plus cos squared. This one's just going to equal to 1. This is just the identity, really important one. So then if we use this, we just rearrange this. So we'll put the negative here, put this over the other side. We'll get negative sine squared h over h cos h plus 1. So now we have this negative sine squared h there. Using that. So now, these parts just I forgot to put the limits here and whatnot. Limit h approaches 0. This is just technically I forgot to put the limit h approaches 0 here and here. This is just technically, you gotta include them there. But so anyways, so now if we remove this squared there, we just have. So we'll just write what we have here. Limit h approaches 0. We'll have let's go negative sine h. Just this is just equal to sine h here, divided by h. This is the limit. This is cos h plus 1. So now we have two limits that we can actually solve. So then this one here is sine squared h. Put it out there. So then this is going to equal to limit h as h approaches 0 of, let's say, negative sine h over h. Well, you can take the negative out. Just put the negative out here. Doesn't affect it. Times by limit h approaches 0 of sine h cos h plus 1. So now we have two limits we could solve. We know that this one here is going to be 1 or negative 1, because we know this limit here it goes to 1. Okay, so now so basically we just get rid of that. So this is 1, and then here if you put h as 0 here, this is going to have sine h is 0, so we'll have 0 over, this is 1, so 1 plus 1. So if we put all together, limit, I'll just get it here, limit h approaches 0 of cos h minus 1 h is equal to, well, this is going to be -1 times 0 over 1 plus 1 equals 0. So if it equals 0, so then this one here is going to be sine x times 0, and all we're left with is this cos x. Or here, yeah, this is going to be equal to 0. This is sine x cos x. So now we're left with cos x. So there's our proof. So then we get that the f prime of x is equal to cos x. So we just proved what we initially saw from the graph. Or we'll get, or we could write it as d over dx sine x equals cos x. And there you have it. Hopefully you learned how to derive it. But yeah, you can see the links below for all the identities that I used here. But yeah, anyways, thanks for watching, and hopefully you learn, and stay tuned for another math easy solution.